this problem, we have a kid kicking a skateboard to his friend. Now it makes it 3/4 of the way there when the initial velocity is 2.4 meters per second. So what does the velocity need to be off the start in order to just make it to his friend who's a distance x away? Okay, now we know that the work done on something work is just energy. So in this case, our work done is just the change in kinetic energy. Net work is equal to the final kinetic energy minus the initial kinetic energy. So what we're going to do is we're going to say the net work done is equal to kinetic energy final minus kinetic energy initial. Now the final kinetic energy of the skateboard is 0 because it's not moving. 1/2 mv squared is 0 when v is 0. So we can say work net. Work is just force times distance. Now the force acting on it, if we draw a free body diagram of just this skateboard, we have the force of kinetic friction, which is equal to mu Fn. We don't know mu. And we have also acting on this, we have weight acting downward, we have the normal force acting upward. So those are the forces acting on this skateboard. So now the work done is done by the kinetic friction force. So work done is force times distance. Force is Fk. Distance is going to be 3/4 x. And what this is going to help us do is actually we're going to figure out mu to start, and that's going to let us figure out the total distance, or the total velocity that we're going to need to make it the total distance. Force times distance equals negative kinetic energy initial, negative 1/2 mass of the skateboard times v squared. V is this, so we can just put in v naught squared. So Fk is mu Fn, and if we look at this, we don't know what Fn is, but we can figure it out by doing sum of the forces in the y direction. So just right up here, I'll do sum of the forces, y direction equals 0. We have Fn minus W. So our normal force minus the weight equals 0. Normal force equals weight. So for Fk, I'm going to plug in mu Fn. Mu Fn is equal to mu Fn is W. So Fk is mu times W. W is just mg. The weight is just mass times the gravitational constant. So mu mg. So I'm plugging that in for kinetic friction. So Fk is mu mg. We have 3/4 x equals negative 1/2 m v naught squared. Okay, so what do we know here? We can cancel, divide the m's, and we can say that the net work done was negative because it was acting. The force was acting this way, and the motion was this way. So by defining x, y, with x positive that way, the friction force is negative. So that means that this net work has to be negative. So we put that negative sign in there because it's acting in the negative direction. So we have the m's canceling, and then we have mu we don't know, g is a constant 3/4, x we don't know, and v squared we don't know. So we plug in, we can solve for mu. We'll just say mu equals, we cancel out the negative 2, we can just divide both sides by negative 1. Mu equals, and I'll multiply 4 over, so I got 4 over 3 times 2, 6. Divide g to the bottom, put x to the bottom, and v naught squared on top still. Okay, so that's our term for mu. Now what we do have to do is look at the total distance for the other one when we actually make it. So we can do the same thing. Net work is this. So we can say work net. Now the final kinetic energy is still 0. So the initial, and the same with the initial kinetic energy, we have negative 1/2 m v naught. We'll call it v naught 2 this time because it's a different initial velocity. And the work net is going to be different again. This time it's negative Fk x. So force times distance. Force, this is a different distance now, it's the total distance. Negative 1/2 m v naught 2. And we know that Fk is mu mg, same thing. So we have negative mu mg x equals negative 1 mv naught 2 squared. Okay, we're looking for v naught 2. So I'm just going to solve for v naught 2. And I'm going to end up plugging mu into here so we can get rid of mu. And our x's will end up canceling. So solving for v naught 2 squared. That's equal to, negatives will cancel out. So I multiply the 2 up to here, so I have 2 mu gx. I'm just writing this out again, and I'm canceling out the m's. So I multiply the 2 up here, so I have 2 mu gx, right like that. And that still just leaves me with v naught 2 squared on that side. Now I'm going to plug mu in there, so I'm going to take this mu and plug it in over there. So we have 2 times 4 over 6 v naught squared over gx times mu just gx. I was plugging in for mu, so mu is not there anymore. That's what I plugged in for, so times gx. As you can see, gx cancels, divides out. And we have 2 times 4 over 6 times v naught squared. And these are all just numbers now. So we have 8 over 6 times v naught squared. Our initial velocity is 2.4 meters per second. 2.4. And this is what v naught 2 squared is. So v naught 2, I take the square root of both sides. And that equals root 8 over 6, 2.4. And if I plug that into my calculator, it gives me an answer of v naught squared. This is squared here. V naught squared, I put the v naught squared. And so I plug that into my calculator and it gives me an answer of 2.77 meters per second.